We stand at a unique moment in history. Millions of people interact with artificial intelligence assistants every single day. They share their hopes, their work, their questions, their secrets. This creates a vast ocean of information. Companies that build these AI systems can see these daily interactions. Yet for researchers and the public, the data available is incredibly scarce. There is a significant gap between what happens in private AI chats and what we can publicly study. This data gap is a serious problem. It makes it very difficult for us to understand how these powerful tools are truly being used. Without this knowledge, we cannot easily identify what works well, what fails, or where hidden dangers might lie. This challenge presents a fundamental conflict. On one hand, understanding user interactions is crucial for improving AI systems. We need to learn from real-world use to make them more helpful, more reliable, safer for everyone. On the other hand, the content of these conversations is deeply personal. People discuss their health problems, their financial worries, their creative ideas, and their intimate relationships. Protecting the privacy of these individuals is not just a legal requirement, it is an ethical imperative. We cannot simply allow human reviewers to read through endless streams of personal chats. This approach is slow, expensive, and poses a significant risk to the mental well-being of the reviewers themselves. To navigate this difficult situation, we need new methods. We require tools that can bridge the gap between the need for insight and the non-negotiable demand for privacy. A system called Clio was developed to address this very problem. Clio is an analytical pipeline designed to find meaningful patterns across millions of AI conversations. It achieves this remarkable feat without exposing the sensitive, private details contained within any single chat. The system is engineered to provide safe, aggregated, and clear facts about how large groups of people use AI assistants. It offers a way to see the forest without inspecting each individual tree. The creation of Clio was driven by this urgent need for responsible oversight. As AI becomes more integrated into our lives, our ability to study its impact must keep pace. We cannot afford to operate in the dark, guessing about how these technologies are shaping our world. Systems like Clio represent a critical step forward. They offer a potential solution to the data dilemma, allowing us to learn from the vast scale of AI usage while upholding the fundamental right to privacy. This allows for a more informed and cautious approach to building the next generation of artificial intelligence, ensuring it serves humanity well. The Clio system was built with a clear and focused purpose. The primary goal was to create a method for understanding large-scale AI usage patterns in a way that rigorously protects user privacy. The developers wanted to answer big questions. What are the most common ways people use AI assistants? Do these patterns change across different languages or cultures? Can we detect new forms of misuse or harmful behavior as they emerge? To answer these questions, Clio was designed as a multi-step pipeline. Extract facts, group similar chats, make safe summaries, check privacy, build a map. Each stage transforms raw, sensitive data into safe, high-level insights. It acts like a refinery, taking in crude information and outputting a purified, useful product. The process begins with the first step, extracting facts. When Clio analyzes a conversation, it does not keep the entire chat. Instead, it uses an AI model to read the conversation and pull out a short list of key facts. These facts might include the primary topic being discussed. For example, software development. For example, creative writing. It might also note the language used, or the general sentiment expressed. The system is programmed to only extract the specific, necessary information needed for analysis. All the raw conversational text with its private names, places, and details is immediately left behind. This initial step is crucial for minimizing the amount of sensitive data the system handles. Once the key facts are extracted, Clio moves to the next stage, grouping similar chats. The system takes the facts from thousands or even millions of conversations and begins to look for similarities. It automatically sorts the chats into distinct clusters. One cluster might contain thousands of conversations all related to writing Python code. Another cluster might group together chats where users are asking for help drafting professional emails. Each cluster represents a significant, recurring pattern of use. By design, a cluster is only formed if it contains a large number of conversations, which prevents any single unique chat from being isolated and identified. The final steps of the pipeline are focused on summarizing and verifying the findings. For each large cluster of similar chats, Clio generates a concise, artificial summary. This summary describes the common theme of the cluster without using any real text from the original conversations. For instance, it might say, "This cluster represents users asking for assistance with debugging code in JavaScript." Before any summary is finalized, it undergoes an automated privacy check. This check ensures that no personally identifiable information has accidentally slipped through. If any potential privacy leak is detected, the entire cluster is discarded. The safe, verified summaries are then used to build an interactive map, allowing teams to explore the landscape of AI use. Clio's approach to privacy is not based on a single trick or a simple lock. Instead, it uses defense in depth. That means multiple independent privacy layers at every stage. If one layer fails, others remain to stop a breach. Together, they form a fortress around user data. Automation, aggregation, auditing, summarization. The first rule: human analysts never see raw conversations. The pipeline, from fact extraction to summarization, is fully automated. That minimizes human exposure to private content. The system uses aggregation and differential privacy principles. Aggregation means Clio never reports on a single conversation. It only describes patterns across large groups of chats. A cluster must contain a very high number of conversations before it can be analyzed or summarized. That makes it statistically impossible to trace a finding to one person. Even if you knew someone was in a chat, you couldn't find which cluster was theirs. Large group requirements prevent re-identification. Clio also actively sanitizes outputs automatically. Summaries are not simple averages. They are synthetically generated by another AI model. The model describes cluster themes in generic terms and omits specific details. It omits unique details. It omits private details. After generation, summaries go through an automated privacy filter. The filter scans for names. The filter scans for phone numbers. The filter scans for addresses. The filter scans for other personal information. Any flagged summary is removed from the final output. Finally, the whole system is rigorously tested and audited. Developers ran extensive attack simulations and red team tests. They tried to reverse engineer outputs to uncover private data. The research showed the system is highly resilient. Layered controls make private info undetectable in the topic map. Ongoing auditing and red teaming keep the privacy fortress strong, even as Clio analyzes new and different conversations over time. To test its capabilities, Clio was used to analyze a massive dataset, 1 million real-world conversations from users of Claude AI. The analysis provided a panoramic view of how people are integrating this technology into daily life and work. The findings painted a vivid picture of user behavior. One dominant pattern was coding and programming. Coding, writing and editing, research and study. Many conversations involved writing code. Many involved debugging. Many involved learning about software development. AI assistants are acting as partners in complex technical work. Another major theme was writing and editing. People used AI to compose emails, to draft reports, to create stories, to refine resumes. This shows AI as a universal communication aid. Clio also found a big cluster for research and learning. Users asked it to explain complex topics, to summarize long articles, to find factual information. Usage patterns varied across cultures and languages. Japanese chats had more discussions of elder care and social support. Spanish chats showed more interest in economics and finance. These insights show AI adapts to different community needs. Clio flagged potential misuse and safety issues. It detected coordinated, automated attempts to abuse the service. It surfaced academic dishonesty attempts. By clustering behaviors, safety teams can see the scale without reading thousands of reports. That lets them act faster, updating safety filters and developing new policies to discourage harmful use. The Clio system offers a vital contribution to the ongoing development of artificial intelligence. It provides a practical and effective way to learn from real-world AI usage at a massive scale, all while maintaining a strict commitment to user privacy. By revealing what people are actually doing with AI assistants, it helps to replace guesswork with evidence. The findings from the analysis of 1 million conversations are a clear demonstration of this power. They show us where users find the most value, coding writing research, and also reveal where new risks and challenges are beginning to appear. This knowledge is essential for building better, more helpful, and fundamentally safer AI tools. For any organization that deploys large-scale AI systems, the principles behind Clio offer a clear and practical path forward. The first and most important recommendation is to build for privacy from the very beginning. Privacy should not be an afterthought or a feature that is tacked on at the end. It must be a core component of the system's design. This means thinking about data minimization and automation from day one. Organizations should strive to collect only the data they absolutely need, and should automate analysis wherever possible to reduce the need for humans to view sensitive user content. A layered defense strategy is also critical. Organizations should not rely on a single privacy method. Instead, they should combine multiple techniques: strong aggregation requirements, automated sanitization filters, and regular, rigorous audits. This defense-in-depth approach creates a much more resilient system. It is also important to monitor usage patterns continuously over time. As AI models are updated and user behaviors evolve, new patterns of use and misuse will inevitably emerge. Ongoing monitoring allows safety and product teams to adapt quickly to these changing dynamics, addressing new risks before they become widespread problems. Finally, systems like Clio enable organizations to act with greater speed and intelligence. They help safety teams move from a reactive posture, where they respond to individual incidents, to a proactive one, where they can identify and mitigate systemic risks. The high-level insights generated can also be shared more safely with the public and with outside researchers, fostering greater transparency and collaboration. By embracing such privacy-preserving analytics, we can support the needs of real users and protect their privacy at the same time. We can illuminate the path forward, ensuring that the development of AI is guided by understanding, not by assumption.